So that is basic concept, but we are trying to give a brief introduction to test and measurement, and we have to touch certain other concepts. However, since we have said test, when you say test is an instrument, you see that instrument called test, before it can really be a test in the real self, it must possess certain qualities. If your test does not possess those qualities, they are not really good tests. I use the word good tests just because they are still tests, but they are not a good test. So for you to say a good test, they must possess, so the word good is underlined. For you to say a good test, they must possess certain characteristics. And one of the most important characteristics is not even one of the most important, the most important, although there are other characteristics, but the most important characteristic of a good test is validity. So any test that is not valid is a test, but it's not a good test. Just like we human beings too. Anybody that is not trustworthy doesn't mean that person is not an human being, but the only thing is that that person is not a trustworthy human being. So using that analogy, any test that is not valid is a test, but it's not a good test. And validity is the most important characteristic of a test. However, if a test does not possess this, all other characteristics is meaningless. But if a test possesses all other characteristics and is not valid, probably you still have to just do some other things and make it valid. Any test that possesses all other characteristics will have more tendency to be more valid, except otherwise. So validity is a characteristic of a good test. Let me mention some other few characteristics. One of the sufficient conditions for validity, which is also a characteristic of a good test. When I say sufficient, validity is the most important characteristic. It's a sufficient condition to determine a good test. But one of the necessary conditions for validity is another characteristic we call reliability. Reliability. A good test should also be what? Reliable. So reliability is a necessary condition for validity. So when a test is valid, it is also reliable. When a test is valid, it is also reliable. When a test is reliable, it may be valid. That is trying to tell us that a test may be reliable but not valid. But once a test is valid, it must be reliable, which implies that when we are talking about test validity, the moment a test is valid, it will have more tendency to be reliable, and in fact it will be reliable consistently so far it is valid, except other factors that can affect validity or reliability of test, which is different from the test itself. If it is the test, you are not looking at other factors, it will be reliable. So once a test is reliable, once the test is valid, it will be reliable. So reliability is a necessary condition for validity. Another characteristic of a good test, let me just mention them, is that it will have to discriminate well. So it will possess discriminating power. So the items on the test or the question, so when we say items, we mean question. The items on the test must be able to discriminate. So we have discriminate well, discriminate well, which implies that it must be able to discriminate between those who know and those who don't know in terms of the items on the test. So any test that does not discriminate well, that means it's not a good test. You cannot really determine those who understood the concept or those who have learnt then that is not a good test. Everybody is getting it, everybody is missing it. It's not really a good test. So it must have both floor and ceiling effect, meaning that it must not be too easy and must not be too difficult. That is another thing for another basic thing that we need to explain some other time. A test must be usable. So anything you obtain from the test must be usable. If you are just doing test and you are not going to use it for anything, then it's not really a good test. Why are you just doing it? Tests are meant to obtain information. You can use it to determine teaching effectiveness. You can use it to ascertain the strength and weakness of students, and so on and so forth. You can use it to diagnose. So if you are not using them, all those uses of tests for selection, for placement, for diagnosis, for certification, you are just doing it for doing sake, then it's not really a good test. Because once you are not using it, then it doesn't really make sense. So usability, a test must be usable, practicable, as well as economical. You have to consider the resources available and determine time. Time is also a resources. Time, resources available in school, and so on and so forth. You know that you are teaching in a rural area where there is network problem and you want to use technology assisted, or let's say online assisted examination. You know practically that it is not suitable. That people will not even have opportunity to log in if they want to really log in, and that may hinder the effectiveness of your testing. So practically, that is not going to be a good test in that scenario. You know, in your school, you hardly have resources in terms of money or paper to print, and you want to print your questions and you want to practically, you look at resources. If that is not going to work out, you look at what will work out and you will streamline your test in that regard so that it will be economical. So those are characteristics of a good test. However, we are going to try to look at these first two because they are very important. Let us start from validity. So when we say validity, what do you mean by that? When they say a test is valid, more importantly, the word validity, if a test is measuring what it's intended to measure truly well, that test is valid. So a mathematics test that is measuring what it intended to measure, which is mathematics achievements. So that means the construct of interest is mathematics. So that test is valid. You cannot be using A to measure B. Cannot be using B to measure C. So if you are trying to measure B and you are using instrument that will measure B to measure B, then that's valid. It means that if you are testing or you are constructing tests and you want it to be valid, you ensure that it is measuring what you really want to measure in the real sense. So that's validity. How do you then know that a test is valid or not? There are various types of validity. We have what we call translational. It will translate to, and we have the main validity concept, and we have the other validity concepts that are broader than this. So translationally, we have what we call the face validity, and we have the content validity. But majorly we have the other ones, which is the construct validity and criterion-related validity. So when I say translational, it implies that these first two will translate. It will translate to others. If a test does not have good face validity, though face validity is the weakest form of validity evidence, but it is also important. They will say you cannot judge a book by its cover. A test that lacks face validity may not be a good test or may not be a valid test just because of that face validity. So when we say face, how that test looks structurally, in terms of arrangement, ambiguity. A test that is ambiguous lacks face validity. A test that is not arranged in a way that it will not create confusion, then is face valid. Legibility, a test that is clearly written such that students will see it even when there is no light, when there is light, when their eyes are not really good, when they are using glass, it will be legible, then it will possess face validity. An example of face invalid tests are tests that teachers will have to come and tell you, go to question this, write that. It means that if they are not around, there will be confusion. So that test lacks face validity. So if a test is not well formatted structurally, is not legible enough, does not really look in a way that it will be clear with good instruction and so on and so forth, that test assumes to be face invalid. But it is important that you package your test to look appealing, well arranged, well formatted, without ambiguity, legible, and so on and so forth. Then it will possess face validity, such that when they look at it, even without looking at what is inside, it will make sense to them, and they'll say, oh, this is a good test, but it is the weakest. But even with that, it can affect others, it can translate to others. Another important thing is the content validity. If you look at a test and you have only taught, let's say out of 10 topics, you have taught just 2 topics, and your test is covering all the 10 topics, that is not a content valid test. So content validity is looking at whether the test really is a representative or adequately possess the content of instruction. So when I say, when there is a representative or adequacy of content covered during teaching, if your test adequately and representatively possess the content that you have taught or expose the student to, then that test is content valid. So this one is trying to look at adequacy and representativeness. So representativeness, a test that lacks content validity will be a test that is supposed to be measuring A, B, and C, but eventually is measuring C more. That means it is not a representative of A, B, C. It's measuring more of C, in fact 80% of C, 10% of B, and 10% of A, while you have taught them in the right, in giving the same effort, but you decided to make it lopsided, then such a test is content invalid. Or you have taught A, B, C, you are now asking D. That is even the worst. That one does not even capture any content that you have instructed. You went ahead. Let me make a clarification. If you are teaching A, B, C, and you have exposed students to how they will get D using variety of approaches, and you have made them go into self-directed learning, and you have made them probably report back to you or give them as an assignment, and you are now asking them D, that is not out of place. So it implies that you will not just ask them D alone. If you go into the exam and ask D alone, it is still not content valid. It does not represent A, B, C, D. It's only D alone. So students that have knowledge of A, B, and C, just because they cannot answer D where you have focused all your items or your question from, you now decide that they have failed. No, they are not the one that have failed. It is the test that have failed the content to be content valid. And once a test is content invalid, you cannot get any good thing from it. Any decision you are making from such kind of test will also be what? invalid. So if your test does not have adequacy and representativeness of the content covered in the classroom, any decision you are going to be making from there will be invalid. But if you have covered what you have taught, captured it well, representatively, you taught a topic for 3 weeks, another topic for 1 week, another topic for 5 weeks, it implies that more questions should come from that of 5 weeks because you have covered a lot. But if you are now taking the one you taught for 1 week, you are taking 50% of the question from that, and you are taking 20% from 5 weeks, 30% from 2 weeks. Anybody that has given effort during study to read more into that of 5 weeks because it's voluminous and the person is now failing, your decision is also invalid because your test is not adequately or representativeness of how, to what extent you have covered. So anybody that read a material for 5 weeks and read it very well, just because you only ask one question from there, the person was unable to answer others, and you now tell the person failed. That person is not really a failure. It is the test that has failed to be content valid. More importantly, the construct validity. This is the latent variable of interest. The latent variable of interest. Construct. In reality, we don't really have unidimensional tests. What do I mean by that? A test is supposed to be measuring one thing at a time. But in reality, we have tests that are not really unidimensional. Though efforts have been made to ensure that they are more of unidimensional, but they are not really unidimensional. Meaning, they can only have a dominant construct that they are measuring. The other one will be recessive. It will not take charge. Let me cite an example. English is used as a medium of instruction, and you are trying to develop tests to measure physics or mathematics knowledge, and you have exposed them to mathematics, you have taught them a lot of topic, but you are using English to ask those questions. The knowledge of English is also needed. Somebody that does not really understand English language, just because of that, you use certain words, though they may be straightforward to you, but because of proficiency in English, that person will not be able to attempt that question. So it means that that's another construct, but it's not the main construct. It will only affect the main one in a small measure. But you are not going to be setting tests that it is only English knowledge that will dominate. In physics, if you set questions that the knowledge of English is very, very important, and if it is very, very important, it means that your physics test is construct invalid. They will be reading for physics, but when they enter into the exam, they will see more of English, such that it is that English knowledge that they will allow them to attempt some questions in a way that it will influence it more. Probably you are also giving your marking guide and you are specifically marking their English language, whereas you are supposed to be looking at their response with respect to physics construct. So when you are developing tests, you ensure that all other constructs are recessive, while your main constructs are what? Dominant. You are teaching English, for example, and you know that English is not their native language, it's a second language. What you taught them in English should be more important than probably other things around English. But because you are teaching them English, you expect them to know how to do other things, but you should focus on what you taught them, and that's the construct of interest. That's the variable you want to exhibit or determine the extent to which they process. So don't let other things affect what you are measuring. So you ensure that your test is covering what is supposed to measure, the variable of interest. Any other variable should not interfere to a large extent, but can be minute. Let me cite an example. Computer-based test that is used by certain examination bodies, even in Nigeria. That computer-based test, the proficiency in the use of computer is such that if it is not a construct, it's a construct that is recessive, but it can destroy even the main construct. Somebody that is having phobia to use computer but very good in mathematics, it will affect the mathematics construct, because that will affect maybe the speed and accuracy of the person or the usage, and the person will not be able to attempt those questions truly well. But if you are very good in mathematics and you have basic proficiency, you will be able to attempt the mathematics, and just because you don't really know more of computer, but you know the basics. So in that case, the construct of interest is mathematics achievement, but another construct is proficiency in the use of computer to attempt it, but it's a recessive construct, not the main construct. Similarly, when you are now doing computer as a course and you want to use computer based test, it is the computer knowledge, not the use of computer to access to attempt question, that will matter, which is the computer knowledge that will form the main construct. Without wasting much of our time, the criterion related, just like the name implies, a criterion, that means there's a standard. There's a what? There's a standard for comparing. So they are basically divided into four: predictive, concurrent, convergent, then divergent. So when we say predictive, concurrent, convergent, and divergent, criterion related, there's a standard of comparison. And when we say standard of comparison, it means that the test you are using, you are comparing with a similar or different test that is of standard. So when you are comparing the test, when I say test, score obtained from the test. So it implies that you are looking at the score you obtain from the test with a test that will occur in the future. When we say in the future, when that future comes, you obtain a score, you now compare it with a standard. That means it has happened before. Then that's predictive. If you are trying to look at it at the same time, though almost at the same time, because it may not really be at the same time, one may go before the other, but very, very close. Let's say, for example, you use a test now, another similar test, you use it tomorrow, but the one you use now is the standard, the one you use tomorrow is the one that you want to compare, then that's concurrent. You are trying to compare the scores obtained from those tests almost at the same time. Similar to simultaneous equation. Even in simultaneous equation, you will solve one before the other. So that implies that concurrently, you are comparing a test with a standard one almost at the same time, one after the other, but very, very close. Unlike predictive, that has to do with future. So predictive has to do with future, concurrent has to do with almost at the same time. Then convergent. Convergent means you are trying to look at whether they are related. Then the opposite is divergent, whether they are different. So if you are comparing a score obtained from a test with a standard score obtained from a standardized test or a criteria, that means a basis for judgment, and they are related, then you are exploring what we call convergent validity evidence. If they are different, you are exploring what we call divergent validity evidence. So I have to say this: a convergent validity may be concurrent or predictive. A divergent validity evidence may also be concurrent or predictive, meaning it can be almost at the same time or in the future. So that implies that even if you are establishing convergence and they are similar, but you do one now, then maybe after a very long, when you say very long, that very long is relative, but not almost at the same time, a very long time, you also compare with something that will occur later on, not almost immediately, but they are related. You are predictably converging to gather evidence to which whether that test is really measuring what it's supposed to measure truly well. We will be talking about reliability in our next episode. Just like I have said, reliability is a what? A necessary condition for validity. So it means that if our test is not reliable, our test cannot be what? Valid. So I will urge you to watch the second episode where we will be discussing reliability, test scoring, and reporting. Because by the time you are able to understand the fact that tests are valid and reliable, then you will go ahead to use them, you obtain score from them. How do you then score those tests? Is also important. After you might have scored using variety of approach, how do you then report those scores? Because a test score must be, the feedback obtained from test is also important as the test itself. So if you do not give proper feedback to a test, that implies that that test is not usable, violating one of those characteristics that I have mentioned earlier. So in the next episode, we will be talking about reliability of tests, how to go about scoring tests. Once you have developed them and used them, then how do you report them? In this next episode,